Okay, today we're going to continue learning about exponential functions. We're going to start looking at them as either growth, exponential functions that are growing, or decay, exponential functions that are getting smaller. So again, we're going to have the same equation that we were using last time. This y equals ax plus b. The a is our initial amount. I'm going to just put initial amount, or you could also call it the y-intercept. And then the b, that was our common ratio. What we're going to actually look at is how that b is come up with, if it's a growth ratio or a decay number. So first, let's just start with exponential growth. So with our exponential growth, we're actually going to break down what that b is. So we're still starting out with our initial amount, but then our b, the way we come up with it is it's our rate of growth. So we can go ahead and just put, this is going to be our rate of growth. And what it is going to be is this little formula right here, 1 plus our rate as a decimal. So this number right here is going to have a decimal, or it's going to be a decimal number. So 1 plus the rate as a decimal will give us our rate of growth. So we just call this right here our growth factor. Okay, so all we did was we took our common ratio, which is what we worked with last time, what we were multiplying the table by each time, and we're breaking down what that common ratio is. And it's really either our growth factor or our decay factor. So let's look at the decay factor. Again, we have the a, which is our initial amount. That's our starting point. That's our y-intercept. And then we have our rate of decay. So our b is actually broken down into a formula. When we were growing, notice that we added 1 plus r, but now we're decaying, and so it's going to be 1 minus r, or minus our rate. And just remember, this is going to be a decimal. We're going to be working in decimals, and once we take 1 and we minus our rate, then that's called our decay factor. Okay, so how can you tell if something is a growth or a decay function? It's real simple. You're just going to look at the b. If your b is greater than 1, you've got a growth factor. If your b is less than 1, you've got a decay factor. So that's really all there is to it. So let's go ahead and take a look at some of these and run them through as examples. Make this get a little better. Okay, on number 1, I'm just going to write our formula up here above it. Y equals a, and this is our b, to the x power, or t power in this case. Okay, so my growth rate. My a is the 350. That'll be my y-intercept. That's my initial starting amount. And then my rate. It's 1 plus a number or 1 minus a number. Since we're doing 1 plus a number, the plus number we're adding is 0.75. And since it's a plus, we know that it has to be growth. So now we're just going to put this into the y equals button of our calculator, and we want to find out when t equals 5. Now remember, when we're using the y equals key on our calculator, instead of a t, you're going to have to use an x. So really, we can go to the table and we're going to be looking at when x equals 5. Our approximate y will be what? Okay, so everybody put that in your calculator. And our approximate y is going to be 5,000 744.58. That's our approximate y value. Okay, so now let's look at number 2. Since that one was a growth, let's look at a decay value. So on a decay value, same thing, we have our y equals a, that's our initial amount or our y-intercept, and then b, our, in this case, decay factor to the x value. Okay, so there's our formula. Okay, our a in this case is 575. Our b, not really looking at our b, but our rate, the thing that we're subtracting from 1, is 0.6. And since we are subtracting, it's going to be a decay. Okay, so again, we're going to put our equation into the y equals key, and then we're going to go to the table where our x is 5, our y is approximately 5.89. So knowing that we started out with 575, and just in five numbers up, we're all the way down to 589. It's showing a pretty sharp decay. Okay, I want you to pause your video and do number 3, 4, and 5 on your own, and then come back and check the answers. Okay, on number 3, they tried to kind of pull a little bit of a trick in that they didn't expand out what your growth or decay factor was. All they did was put that it was 0.5. So since we know that 0.5 is less than 1, we know we're dealing with a decay. So when we put it in as an equation, it would be 1 minus 0.5 equals 0.5. Okay, on number 4, you also had to calculate what your rate was by taking what they put in the parentheses, the whole b value, and subtracting 1 from it. And that gives you your answer when t is 5. Okay, and the trick on number 5 is that you have to go ahead and put that 1.8 in parentheses and assume that the initial amount, starting amount, or the y-intercept is 1. And then to find our rate, we took 1.8 and we subtracted 1 from it, leaving us a growth of 0.8 and an answer when t equals 5 of 18.9. Okay, so on number 6, we are given a table. Okay, now having it as a table, you've got a couple of choices. We know it's exponential, so you could put this table into your calculator and do stat edit, enter it in, and then do stat calculate 0, which is exponential. If we do it that way, the calculator goes ahead and confirms what we already know is our y-intercept, our initial starting amount, is 270. And then it tells us that our common ratio, or how much we're going down by, is 0.33, or 1/3. So this thing is going down by 1/3 each time, or 0.33. Now, to figure out our rate, the 0.33 is not our rate, that's our decay factor. We're going to have to take 1 minus 0.33, and that gives us approximately a 0.67 as our rate. Okay, turn the page. Okay, so let's start putting it into a real-world situation. And so we're going to look at number 7, and we're going to pick out the important data. So when we read it, in 2005, there were 100 rabbits in the park. This population increased. That means that we are dealing with growth at 11% per year. So we got to turn that 11% into a decimal, which would be 0.11. So let's start with our initial amount. Our A, that was pretty simple, is the 100 rabbits. Now our B, our rate of growth, is going to be 1 plus our decimal of 0.11. So when we put the whole thing into the equation, we've got y equals 100 parentheses 1.11 close parentheses raised to the power of x. So now we can put that into our calculator and we can figure out what the population will be in 2025. The biggest thing about that is how many years is that? Well, we started in 05, so 2025 means 20 years. So put the equation in our calculator, go to the table, and at 20 years, it tells us that we're going to have approximately 806 rabbits. Okay, so now let's try one with decay. So with decay, we know that we have a $900 sound system. So that would be our starting point. A equals 900. It's decreasing in value. That tells us decay. And it's decreasing by 9%. So that's 0.09 puts it into a decimal. So let's go ahead and put this together. We have 900 parentheses, we're decaying, so it's going to be 1 minus 0.09, close our parentheses, raise it to the power of x. Okay, so take a moment, I want you to take a moment now and look at number 9, and then start the video back up. Get number 9 read and see what all you can figure out. Okay, so when we were reading about these basketball teams, we're just trying to interpret the equation. So we're going to start with the easy thing. This first thing, the initial amount would mean how many teams we started with. And then when we look at our B factor, we can see that B is less than 1. So it's a decay, and our teams, I don't know if that even looks like decay, our teams, D-E-C-A-Y, are decreasing by 1/2 each round, and I get the 1/2 by looking at the 0.50. So the teams are decreasing 1/2 each round. Okay, number 10 is showing us a table. And what we need to do on this table is go ahead and write the exponential function that goes with it. You got a couple of choices. You can put it in the calculator and get it from there, or you can work it on your own, just on paper. I'm going to go ahead and just work it on my own on paper because I can see that my A, my initial amount, is 100. And then I'm just going to divide 110 by 100. And 121 by 110, and I find out that my B, what that ratio is 1.1. So I know it's a growth because I've got bigger. So my equation is y equals 100 times 1.1 raised to the x value. Okay, and our very last one is another real-life situation is a car, so I want you to pause it and see if you can figure it out, and then turn it back on and check your answer. Okay, and I actually ended up sketching my graph, which is what I'm probably guessing you'll do as well. We know that it starts at the y-intercept at 21,500, and down at 6 years, it's down to 9984.69. Our asymptote on this is the x-axis, which means y equals 0. And our equation is y equals 21,500 for the A, 0.88 is our B, to the power of x, and we know it's a decay. If you have any more questions, feel free to come into tutorials.